Okay. Let me do a audio check to make sure I'm looking good here. That's what we need. And check. Okay. I hear myself pretty well. If you come in, let me know if it's good enough. So I'm pulling questions off Reddit again. I'm going to edit this comment that I left. I think I'm going to start just like telling people to post their follow-up questions in the chat so that, I just like want people to engage. It's really hard to tutor when like it's not a back and forth, if that makes sense. Which I know it doesn't. It's like, whatever, Ryan, but it is actually much harder. Right, save, okay, that's better. So, here comes the question, where is this, pictures, date, time, that's the one, alright. So here's our question, let me pull this up a little bit. So, letter to a friend, problem 1, 3 points. The function W it expresses the weight in pounds of Jumbo the elephant in terms of the number of years since the start of 2010. So, t equals 0 is the beginning of 2010. Sketch a graph of the function W, which is equal to f of t there. Okay. So, this probably, could be confusing. Right? If you're like, oh man, I've never seen anything like that. So let's try to massage this into the shape of something that we've seen before, right? I'm going to use long division to do that. So basically I'm going to divide the numerator by the denominator. And I switched 9 plus e to the t is the same as e to the t plus 9. And I'm going to divide that into 1920 e to the t. So e to the t times 1920 equals 1920 e to the t. So then you multiply this back times the binomial there. And we get 1920 e to the t. And this is what? 9,000 plus 8,100 plus 180. And so that is 17,000. Let me just multiply this. So this is 9 times 1920 is 9,000 plus 8100 plus 180. So it's 17,280. Okay, so I'm multiplying it back. So it's 17,280. And then, this is plus like 0. So we subtract this thing. 1920 e to the t minus 1920 e to the t is 0. And then 0 minus 17,280 is negative 17,280. And that is our remainder, because this doesn't evenly divide that. So what that means is that W equals f of t is equal to 1920 minus 17280 divided by e to the t plus 9. So if you think about what this would look like, this is essentially just like a decaying function. And it's negative, so it's reflected across the no, that would be reflected across there, and then shifted up by 1920. So let me double check myself on Desmos and make sure I know what I'm talking about. So I'm going to do 1920 minus 720 divided by e to the t into the x. I'll do, since it's Desmos, plus 9, and let me just make sure that's the same function. So we've got 1920 e to the x divided by x. Yeah, same function. Okay, that's not what I thought it was, but so it would be 0, whatever, and then okay, so I think this is probably like a bad way of explaining it, so let me get rid of that. Alright, let's think of how we would graph this. I'm trying to like come up with a way that you can know how to graph this without cheating like I did and looking at the graph, because I don't know what your conditions will be like if you have to do this on an exam or something like that. So let's think about some points that we can calculate. F of 0, which is the y-intercept, would be 19,000 or 1,920 e to the 0 over 9 plus e to the 0, which is 1920 over 9 plus 1, which is 192. And so that should be the y-intercept. So let's call that point 192 there. So that's going to be on the graph. And then let's think of, you could just do like another value and get a sense of where this thing is. So let's put in 10. So this is going to be 19. Well, let's do 1. So 1920 e to the 1 over 9 plus e to the 1. So, you know, if you don't have a calculator, this is like a little less than 3, and this is a little less than 3. So I'm going to multiply the numerator by 3, and I'm going to divide that by like a little less than 12. Okay, so that is going to be a bigger number because, well, actually, the numerator is growing faster than the denominator because they're growing at the same rate. They have the same derivative. Oh, this has got to be like almost linear. That doesn't make any sense how I typed it in. Let me change the x. Ah, yeah, that makes sense. That's why. I was zoomed out crazy, or zoomed in crazy, so let me change these manually. So we want to be from 0 to, let me put it from like -1 to 11. So a little bit of, yes. Oh, I'm such a moron. Great. Of course I know what this function is. What kind of fool doesn't know? This guy. So let's say 2000. Okay. I'm gonna paste this in here. So here comes this. This is just a screenshot from Desmos. So this point here is that 192, and essentially this does increase about this like linear rate for a while. It's like, it's not linear, but it's like, you know, kind of linear, and then it has this like sigmoid kind of, this is like a logistic curve, which I should know, but I don't know. So then it kind of plateaus there. And yeah, so that's what that is. Then we'll just take this away. That's the curve, you know. How do you want to get that? You can plug in a few values between 1 and like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and you'll be able to like calculate those, or at least estimate them using 3 as E. Powers of 3 for E. It won't be perfect, but it will be close enough that you can get a sense of the shape of this. And I'm too lazy to do that, so I just plugged it in Desmos. So that's the graph. That's A. And then, okay, here's the good bit. Find Jumbo's weights when he was gaining weight at the rate of 360 pounds per year. So when you're talking about gaining weight, you're talking about his change in weight. And not only his change in weight, but his rate of change of weight, because it's like the change over time. So what they're saying is you want to find out, they're using F. So you want to find F prime of t, which is the rate of change of weight, and you want to know when times when that is equal to 360. So the first thing to do would be able to find out what this is and then set it equal to 360. So let's use the quotient rule. So the quotient rule says if we have u over v, and we want to take the derivative of that, like with respect to t here, then we're going to make u prime v minus u v prime over v squared. And so the derivative of the top is 1920 e to the t. The bottom is 9 plus e to the t minus the top, which happens to be the same, times the derivative of the bottom, which is e to the t, and then divided by the bottom squared, so e to the t plus 9 squared. And let's see if we can simplify this. So I'm going to factor out the 1920 e to the t, and then we'll get 9 plus e to the t minus e to the t, which is 9. And then this is over e to the t plus 9 squared. And I saw somebody posted this in there, and I think that must be right. Let me multiply this by 9 and see if that's right. Oh yeah, that's what I just did. That's what it is. Okay, so this is correct. And so this is 17280, 9 times 1920 e to the t over e to the t plus 9 squared. Okay, so this is our derivative. And so let's go back to the question. It says find Jumbo's weight. So you want to know his weight. You want to know f of t at the time when he's gaining weight at 360 pounds per year. And so we need to set this equal to 360. So let's go 17280. 17280 e to the t over e to the t plus 9 squared. we want to know at what time this is equal to 360. We're going to use that to find the weight at those times, or time. So what can we do here? Let's multiply both sides by the denominator. Yeah, so this will give us 17280 e to the t equals 360. And this is times e to the t plus 9 squared. I know that we just multiplied this number by 9 to get that. So I can just, I can cancel 10 from both sides, divide both sides by 9, and that will give us 192 e to the t equals 36 times e to the t plus 9 squared. And then, let's see, this could be like, we got 2 in each of these, so what would that be? 96, and this would be 18, and that would be, so they're both divisible by 6, right? So this would be 32 and 6, which is divisible again by 2. So that's 12. So this is 3. This is 10 plus 82. No, that can't be. Let me just get a calculator. Evenly divides. So this is 48 e to the t equals e to the t plus 9 squared. Okay, let's FOIL it. So we get 48 e to the t equals e to the 2t plus 18 e to the t plus 81, and then I'll subtract 48 e to the t from both sides, so we've got e to the 2t minus 30 e to the t plus 81 equals 0. And so if you notice, this is a quadratic in e to the t, so like I can do a change of variable to make that easier to see. This is e to the t equal x, and so this is x squared minus 30x plus 81 equals 0. Can we factor this? 27 and 3 would do it. So let's do x minus 3 and x minus 27 equals 0. So that's x squared minus 27 minus 3, good, plus 81. Poof. All right, that's awesome. Doesn't usually happen that easy, so that means x minus 3 equals 0, or x minus 27 equals 0, so x equals 3 or x equals 27. Now we have to recall that we did this change of variables to get to here, so let's change it back now. So e to the t equals 3 and e to the t equals 27. Oops. We just did that for convenience sake. I'll take the log of both sides. So t equals log of 3 and t equals log of 27, which is 3 cubed. So this is like log of 3, and this is 3 log of 3. Okay. Nice. We got lots of good stuff happening here. So these are the times at which our rate of change of weight for Jumbo, our lovely elephant friend, is gaining his weight at 360 pounds per year. So those are the times at which his rate of change of weight is increasing by 360 pounds per year. Now, they don't ask us for the times. They ask us for the weights at those times. So we have to plug that back into our original function. Sweet. Which is 1920 e to the t over 9 plus e to the t. So, sorry, this is kind of chaotic. So f of t equals 1920 e to the t over 9 plus e to the t. And we would like to know f of log of 3, which is equal to 1920 e to the log of 3 over 9 plus e to the log of 3, which is equal to 3 times 1920 over, this cancels, so you just have 3 there, and the same with this, 3 there, so plus 12, it's 3 times 1920, and then I can cancel, this would be 4, this is going to be, does that divide evenly? 16, so that would be 480. Yeah, that looks about right. So he's 480 pounds when t is equal to log 3. Then we'll do f of 3 log 3. And actually, I'm not going to write that as 3 log 3. I'm going to put that back in as log of 27. Oops. Because it'll cancel out fine. So this is 1920 e to the log of 27 over 9 plus e to the log of 27. That's just a log rule. If there's any confusion on that, just put a comment in the chat or something. So what do we have here? We've got 27 times 1920 over 9 plus 27 is 36. And this is 3 times 9, this is 4 times 9. We already know that this goes into here. This is 480. 480 times 3 is 12 plus 1200 plus 240 is 14. Oh yeah, that makes sense. 1440. And then, yeah, so these are the weights. So this is the answer to part B. These are both pounds. LBS. Lobs. Okay. Use your graph from part A to check the reasonableness of your answer. Alright, it's probably super reasonable. I have no idea. What's the log of 3 about? The log of 3 is approximately 1. So that's like over here. Why is that not drawing on this? Oh, because it's drawing underneath it. We'll assume that. So here's 1. And what did I say the weight was? Weights are way down here. 480 and 1440. So yeah, it looks about 480. And then, 3 log 3 is going to be a little more than 3. And we said this was 1440. Yeah, all right. Sweet. Looking good. Okay. At what relative rate was Jumbo's weight increasing at the start of 2010? So this is essentially asking us to evaluate the weight function, or the rate of change of the weight function, the derivative, at 0. And you have to recognize, since t starts at this year, at the start of that year, t is equal to 0. So I'm going to change the color so I don't have to scroll around here like a maniac. So this is part C. We want w prime, which I think we're calling f prime of t, and that is this here, which we calculated earlier. So this is 17,280 e to the t over e to the t plus 9 squared, and we want to know f prime of 0, which is cool because that's easy to calculate. This is 17,280 e to the 0 over e to the 0 plus 9 squared. Whoa, squared. Now, e to the 0 is 1, so this is 7280 over 1 plus 9 is 10. 10 squared is 100. We can lose a power of 10 there. We can go a 2 from here. This will be 8, 6, 4, 16, plus 120 plus 8. Yeah, okay. And so this is 8, 6, 4 over 5. This is pounds per year. And, you know, I like improper fractions. I think improper fractions are phenomenal. I love them. But this is like 172 plus 4/5. 1, 7, 2, yeah. Which is 172.8. So, you know, about 172, 173 pounds per year at that point. And D, find Jumbo's weights when his weight was increasing at half the relative as it was at the start of 2010. Do not use a calculator. Okay. So the rate of change of his relative weight is this, and we want it to be half of that. We want to know when it's half of that. So let's do the old color change again. Let's get some nice blue going on here. That's not that different. Let's go orange. Nice burnt orange. Yeah. Okay. So this is part D now. So we want it to be half of this rate, and that's in pounds per year. So how am I going to do that? Let's go half of that. So we want to know f prime of t. When is this equal to? This is 432 over 5. Okay. And so we found that was 7. So the f prime of t, the left side of this equation, is 17280 e to the t over e to the t plus 9 squared. We want that to be equal to half of that, right? Yeah, what are we going to do here? Let's see. Can we... I'm too tired to do this by... Oh, that's beautiful. So I'm going to, like, cross multiply here and then divide this coefficient. And so let me do the cross. All right, let me take a couple steps. So this is after the cross multiplication. So it's going to be 7280 e to the t, or rather, I'm just like multiplying this over to the other side, equals 432 over 5 times e to the t plus 9 squared. So I'll multiply both sides by 5, divide by 432, or you could just think about like, anyway, you know what I'm doing. I'm bringing this over to here. And you get 80 e to the t equals e to the t plus 9 squared. I'm going to check that again because I don't want to like fat finger this and mess it up. Over 432 times 5. Ah, I was way off. 200. Super glad I did that. Okay. Right. Then same thing as before, so this is going to end up with a quadratic in e to the t, so let's just FOIL that out. So we got 200 e to the t, this is multiplied there, equals e to the 2t plus 18 e to the t plus 81. Then we're going to subtract this bad boy from both sides, e to the 2t. So 200 minus 20 plus 2 would be 182, so negative 182 e to the t plus 180, oh, not 181, 81, 81. Oh, that's an unknowable number. Can this be factored? All right, let me actually even just make sure that worked out. So boom, 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 boom. I still don't believe this. 17280 times 5. 200. 18 minus 200, 182. Yup. So there's no way I can think of anything that will factor this. Anyway, this is equal to 0. So let's put it back to a quadratic. Let e to the t equal x. Then this is x squared minus 182x plus 81 equals 0. And let's use the trusty old quadratic formula. So x equals negative b plus or minus the square root of b squared, 182 squared minus 4 times a times c all over 2a. And we'll do a little simplification. And here, I'll go ahead and change this back. This is e to the t. E to the t is x, because we did change of variables. So, calculator time again. Nah, I can't do this. No, I can't screw that. It's ridiculous. Why would I do that? 182 squared minus 4 times 81. Is that a perfect square? Could it be? No. 328 divided by 2. Is 41 prime. Yeah, I think that's prime. 2, 3, 5, 7, 11. Yeah, once we get to 7, we can stop. Okay, that's prime. So this is going to be... Boom. Let me go back and make sure I get this right. So that's 10 divided by 4. Okay, so this is going to be 182 plus or minus. So we'll plot 100, and a 4 is going to give us 20 root 82 over 2, which is going to give us 91 plus or minus 10 root 82. Okay, so E of t equals those two numbers. So if E of t equals 91 minus 10 root 82, or E of t equals 91 plus 10 root 82, we take the log of both sides, and t equals log of 91 minus 10 root 82, and I don't see any fancy tricks to simplify that in any kind of way. Not that there aren't any, but I just don't see any. And yeah, these are the times. Which, let's verify that. So we could do log of 91 minus 10 root 82 is approximately, no, that doesn't. Okay, so this is a negative time. This is a negative number here. So this is a junk. I'm so glad I estimated that, or approximated. That's a junk answer. This is plus. Okay, so this is like 5.2 seconds. So let's go back up to our graph. 5.2. This is 5, 6, 7, so it's like here. Oh, yeah. Yeah, so if we put a tangent line to this, right there, and then we put a tangent line to, we do, good job. Those are, those are pretty close. Let me, 6, 1, 2, 3, 4, 5, yeah. So I don't know how good I am at doing tangent lines, but Okay, that looks tangenty enough for the tangent club. That doesn't sit well with me. I'm not a fan of that. Graphically, that just doesn't look good. I'm gonna go put this on Desmos. Bear with me. So we want that. We want to have y minus. Let's set this up. This is going to be f of x equals now y minus f of log of 91. Come on, friend. 91 plus 10 root 82. So y minus 1 equals m, which we found, oh no, yes, we found was what? 432 over 5, 432 over 5 times x minus log of 91 plus 10 square root of 82. And then I basically want the same thing. So let me copy that and paste it. And then I want x minus 0 there because that's at t equals 0. S. And then this is 0. No, that's terrible. Oh, duh. X. Oh, it's because it's half. Okay. Yeah. That feels right. So I was expecting the slope to be the same, but we don't want the slope to be the same. We want it to be half of what it is. So yeah, that's right. Okay, sweet. I think that's solved. We solved the bejesus out of that, and I feel pretty proud of it. So, what are we looking at time? Maybe I'll do one more. Let's see if I can do one more. That was kind of long. I'm a little tired. Let's see if anyone posted a pretty easy one. Trace. How do you solve this equation? No, not doing it. College algebra, that would be nice, but it looks like it's solved like 100 times. Ooh, somebody posted like a picture. Oh, wow, great. That's super good. I don't even know if this is correct, but it's excellent presentation. Love it. Oh, what are we gonna do here? Let me just tell this person how great they are. Oh, let's check the other subreddit. Geometry geometry. Should I do this geometry one? I think it's kind of old. Yeah. Not in the mood for that tonight. I think I'm probably not even doing anymore. I'm too tired for this. Well, we got a math. Nope. Let's go new. Pre-calc. Maybe I'll do these. Find the inverse of the following functions. Okay. Whoa. That's not what we want. The link. Copy. And paste. Okay, there's that. Let's get rid of all this mess. I'm going to make these in... Can I put like a group? Quick group. Bang. Alright, y'all. Oops. Do. I want you. Nope. Control C. Go up. Nope. Z. We have it here. Alright. Oh, sweet. Okay, got it. And then. That. Let's open this up. Find the inverse of the following functions. Two questions on this. Okay. No, that's two. Let's go one. Okay, so with these, let's go A. F of x equals 2x minus 3, so I'll put this as y equals 2x minus 3. So there's two ways you can do it. You can solve for x and then swap x and y, or you can swap x and y and then solve for y. Let's swap them now. So we've got x equals 2y minus 3. I'm going to add 3 to both sides, and then I'm going to divide by 2. Now this is our f inverse of x. And so this is a linear function, so it is a function. And it is also 1-to-1. So let's say 1, 2, 1 function. Okay, let's do B. So we've got f of x equals root 2x minus 1. So I'll just put that as y equals root 2x minus 1. Last time we swapped them first, so this time I'll solve for x and then swap them just to see it. So I'm going to square both sides. So y squared equals 2x minus 1. And here I want to make like a note for myself that 2x minus 1 has to be greater than 0 for this, which means greater than or equal to 0. and so y has to be greater than or equal to 0 there. So x has to be greater than or equal to 1/2. Just solving this inequality gets me that. And so that'll help us figure out what's going on when we get the inverse. Okay, so I'm going to add 1 and then divide by 2. So y squared plus 1 equals 2x divided by 2. X equals y squared plus 1 over 2. And then we'll swap x and y now. So the first time I swapped it first and then solved. Now I solved and then swapped. So this is y equals x squared plus 1 over 2. And this is f inverse of x. So we need a restriction on this domain. Because we want, so just to sketch this out for you, we're going to have like this here, and then so 2x minus 1 is going to give us redshift, so this is like 1/2, and then if we do, I don't know, 1 will give us 1. Let's call this 1 and this 1. So, okay, there we go. Put these in enough color so you can see them. So essentially it's going to look like that. And if I draw the line y equals x here, which is like that, our graph should look like it got reflected across that line. So let me draw the reflection. So we want to have something like this, and you know it may not be perfectly on either side of that line, but anyway, don't worry about it too much. We don't want this other half of this thing here, because then they are not inverses, because we have all of these values on this side of the function. So we have to keep the original restrictions. So what does that mean? Y is greater than 1/2, and x has to be greater than 0, greater than or equal to 1/4 plus 1. No, 0. Okay, yes. Yeah. This is greater than there. Yeah. So that's our function. I just want to keep the restriction on it. So with the restriction, it is 1-to-1. Because the like x less than 0 is not in its domain. So you may need to argue with your teacher about that, but I think they should probably see it my way after a minute or two of arguing. And if you're worried about it, write that sentence like I kept the original restrictions or something. Like, tell them what you did. You know, make a nice argument. So okay, then f of x equals x squared plus 1. So this is c. Y is that. So I'll swap it and solve this time. So we get x equals y squared plus 1 minus 1 from both sides. X minus 1 equals y squared. Take the square root on both sides. Y equals plus or minus the square root of x minus 1. So this is not a function. Not a function. And then let's go 1 over 3x minus 2. Then we're going to have, so this is y. So let's swap and solve again. So x equals 1 over 3y minus 2. Oh, this is f inverse down here. But it's not even a function, so, you know, function notation is less important. Okay, then we got to solve for y. So x times, so I'm multiplying both sides by the denominator, dividing by x now. And then we'll add 2 to both sides. And I'm going to go ahead and just get a common denominator there by multiplying by 1. That's 1. And so then I can over x. So then I can divide both sides by 3 easily. This is like, this is a function, yes, function. It's rational, so is it 1 to 1? Yeah, this is 1 to 1. I'm pretty sure. Yeah, this is 1 to 1. It's 1 to 1. I have to see the definition and function notation. The way you should think of these is like it passes the vertical test and it passes the vertical line test and the horizontal line test. If you get both of those, you're good to go. E, x over 1 minus x. E. Alright, so this is y. So I've been switching and then solving, so let's solve and then switch. So y equals x over 1 minus x. I'll multiply both sides by the denominator. Y equals, or y times 1 minus x equals x. Then I'll distribute the y. And then I will add xy to both sides. So this is going to be xy plus x. Then I'll factor out the x. And then I'll divide by 1 plus y. And then, so first I solve for x. Now I'm going to swap the variables. So y's become x's, x's become y's. Y equals x over 1 plus x. And this is f inverse of x. Is it a function? It looks like a function. Yeah, it's 1 plus 1 over x plus 1, which is a function. And it is 1 to 1. This is 1 to 1. And then f is 2x minus 1 over 3x plus 2. Alright, so this is y. Let's solve for x and then swap again. So this is multiplying by the denominator on both sides equals 2x minus 1, distributing y. Now I'm trying to solve for x. I'm going to put all my x's on one side and everything else on the other side. So I'm going to go 3xy. I'm adding 2y and subtracting 2x. So minus 2x equals 2y minus 1. So what did I do? I added 2y, minus 2x, minus 2x. I just did that in one step. Then I'm going to factor out my x. X times 3y minus 2 equals 2y minus 1. Divide both sides by 3y minus 2. X equals 2y minus 1 over 3y minus 2. And then now I'll swap x's and y's. So y equals 2x minus 1 over 3x minus 2. And this is f inverse of x. And is it a function? It's a function. And I also think that it is 1-to-1. Okay, so I'm pretty sure this is a 1-to-1 function. I'm going to check this one and the last one just to be sure based off the definition. So let's call this 1-to-1, and you can just put a box around that and ignore the rest of this, or you can hold on for dear life. So, so we want f inverse of a equal to f inverse of b, and so that's a over 1 plus a equals b over 1 plus b. Yeah. Right? A times 1 plus b equals b times 1 plus a. And then we get a plus ab equals b plus ab. And then we subtract, so a equals b. Okay, cool. And then, so we'll do the same over here. So a f inverse of a plus b. Let's be creative. So what are we going to get? So we're going to get 2a minus 1 over 3a minus 2 equals 2b minus 1 over 3b minus 2. Cross multiply 2a minus 1, 2b. This is 3b minus 2 equals 2b minus 1 times 3a minus 2. We FOIL 6ab minus 4a minus 3b plus 3 equals 6ab minus 4b minus 3a plus 2. No, plus 2. This is also 2 here. Okay, so I'll cancel the 2's. I'll bring so plus 4a plus 4a plus 4b plus 4b. Cancel the 6ab. So we're going to get b equals a. Nice. Okay, everything's 1-to-1. Or the last two are 1-to-1. Not everything is 1-to-1. Oh, I forgot that there's a whole extra problem here. Let me do this other problem. I'm really trying to be consistent on this YouTube stuff. I don't know where this is going, but I figured it's like worth doing it well if I'm gonna do it. Is this right? What am I trying to do here? Let f of x equal this mess. Okay, find the inverses and then do some compositions. Alright, so let's find the inverse. So f inverse, okay, let me actually show my work. Y equals 2x minus 1, so this is a. So we're going to, let's swap them. So x equals 2y minus 1, and then solve for y. We'll add 1 to both sides. Divide by 2, y equals x plus 1 over 2. You're kidding me. Is this the same? No. No, it's not. Okay. And this is f inverse. And then b, or no, it's not even a yet. First we gotta find the inverse functions. So let's go. Y equals 1/2 x plus 3. So what did I do first? I swapped them last time. So this time I'll solve for x first. So subtract 3 from both sides and multiply by 2 on both sides. 2y minus 6. And then swap them. And then this is g inverse. And so what do they want? So for part A, we want f inverse composed with g of x. And so this is, you can write this in the other notation of like f inverse of g of x. It's the same thing. Which I find a lot of people have an easier way of interpreting that. So whichever is good for you. So this is like f inverse of g of x is equal to g of x plus 1 over 2. And then we just plug in g, which is 1/2 x plus 3. So this is 1/2 x plus 3 plus 1 over 2, which gives us 1/2 x plus 4 over 2, which is 1/4 x plus 2. Then part B, is g inverse composed with f inverse. So we want g inverse composed with f inverse of x, and that's the same as g inverse of f inverse of x, which a lot of people prefer that notation. And so we're going to take g inverse, and we're going to plug f inverse in for x. So it's 2 f inverse of x minus 6. That's coming from here. And then we're going to substitute f inverse for that. So x plus 1, so this is 2 times x plus 1 over 2 minus 6, which I'm getting from here. We'll just calculate that one. We cancel our 2's, x plus 1 minus 6, and we get x minus 5. I'm spent. That's all I got. Let's see if anybody came in here. Oh man, this is average watch time. 14 seconds. Oh, crushing me. Okay, alright. It's long tail, man. Long tail. The views are coming. I have complete faith in the universe. People need help with homework. Gotta keep grinding. Thank you for whoever came for 14 seconds, which was probably me. Checking my audio. Thank you, me. And whoever else watches later. I know everybody's asleep right now because they're normal. Yeah, I'll see y'all tomorrow.